Greetings, students. Today we're going to discuss practice test 3-1. First test of third quarter. Good luck. First question here, distance between the points. So the formula is the change in x squared plus the change in y squared underneath the square root. So here's the change in x and the change in y. So we're looking at the x's here, and from 5 to -6. That's a change of 11. Why 11? Because they're opposite signs. So when I take -6 minus 5, I get -11. Because I'm subtracting these guys. -6 minus 5. So -11 squared, which is the same as positive 11 squared. Again, with the distance formula, these values are going to be squared as quantities. So that -11 squared is the same as positive 11 squared. From -5 to -4, that's a change of 1. -4 minus -5, or -4 plus 5, in other words. That's a change of 1. It's 122 total. And there we go. Alright, if you're having major issues here, like I told you before, we're using calculators the rest of the year. Change in x, -6, negative, not -6, -6 minus 5. Change of 11. -4 minus -5. Change of 1. Some of you claim to be really good with calculations. If you're using a calculator, here's your chance to prove it. Or just use number sense like we've been trying to teach you all year. 11 apart, 1 apart. Changing x, changing y. Alright, the slope. The slope's the same items, just divided and not squared and square rooted. So it's the same items. y2 minus y1 divided by x2 minus x1, or in other words, the change in y over the change in x. So the y's here, they changed by 12. They went down by 12. Slope, it does matter if things are going down or up. So it went down by 12. The y's, 5 to -7. And the x's went up by 9. Y's went down by 12, x's went up by 9. You can reduce that, dividing it by 3, and make it into -4/3. Next one, find the interior angle sum. Remember, it's how many triangles, so if it's 15 sides, it's going to have 13 triangles. 13 triangles. It's got 2 less triangles than the number of sides, because 3 sides is 1 triangle, 4 sides is 2 triangles, because you make a rectangle or a quadrilateral when you get 2 triangles put together. 5 sides is 3 triangles, because a pentagon you have 3 triangles in it. So 13 triangles times by 180 per triangle. We don't have to do this part by hand now. 13 times by 180 is going to give us the interior angle sum here, 2,340. That's the interior angle sum. That's the sum of all the inside angles. All of the inside angles on that polygon. Pay attention here, because the next one says each interior angle, which is different than the interior angle sum. So a decagon's got 10 sides, meaning it's got 8 triangles. 8 triangles. Times by 180 per triangle. So 8 times by 180. There's the sum, 1,440. That's the sum. And it says each interior angle, so I'm going to take that sum and divide it by the number of angles. A decagon's got 10 angles. So now I'm going to take 4,440 divided by 10 sides. or 10 angles. 144 degrees for each angle. This one is each angle. This one is all the angles combined together. Sorry, I had something on my desk. Right, exterior angle sum is always the same. Always 360 degrees. Doesn't matter the polygon. Doesn't matter how many sides the polygon's got. So that's a quick question to answer. Each exterior angle, you're going to take 360 divided by the number of sides, or angles. If you want to call it angles, call it angles. 360, there's 16 of them here to divide that into, since it's regular. 22 and a half. Again, different questions. There's the sum of all of them. All the angles add up to 360 on the exterior of a polygon. Here's each one individually. Individually, these are each 22 and a half, because there's 16 of them and they add up to 360 total. Alright, how many sides does the polygon have? If each exterior angle is 2 degrees, how many sides does it have? This is just backwards from number 6. So instead of taking 360 divided by sides, we take 360 divided by 2 degrees, and we get the number of sides. Alright, next thing. 5 interior angles of a hexagon. A hexagon should be 4 triangles. So we're going to take 180 times by 4, because that's what a hexagon should be. 180 by 4. We're going to subtract the given angles. And this will give us what's left over for the remaining angle, for the missing angle. So 180 times by 4, that's what a hexagon should be. 4 triangles. I'm going to take off 101, 112, 147, 98, and 160. So I just took off all the given angles. 101, 112, 147, 98, and 160. I have 102 left over. That's the missing angle. These angles are supplementary because they are consecutive angles on a parallelogram. 17x plus 129 equals 180. 129 from 180 is 51. X is 3. These sides are congruent on a parallelogram. It looks like a rectangle as well, but any parallelogram has opposite sides congruent. X minus 2 is equal to x plus 8. X from 3x is 2x. 2 plus 8 is 10. 2 into 10 is 5. Alright, there's questions 1 through 10. I will make it so half the points are on the front, half are on the back. So there's more questions on the back, but the point values are going to be the same for front and back for my class. So on the back here, PX and VX. PX is half of VX. In other words, VX is twice as long. So what I'm going to do, set 31x plus 1 equal to times this by 2, because then it's equal to Vx. If Px is double, it's equal to Vx. Alright, so x here is 1. 1 from 32 is 31. X is 1. Alright, this one. If ST is 13, that means TQ is 13, which means SQ is 26. There's that first item. Now, if this is a rectangle, the diagonals are congruent. So if SQ is 26, PR is also 26. So these will also be 13s. If it is a rectangle, which it says it is. So PR is also 26. Alright, PRS, 21. On a rectangle, each of the sides, each of the angles is 90. So if this is 21, QRP is 90 minus 21, which is 69. Again, I can use a calculator here to help me out. So I got 21 and 69. QPR is the same as PRS, 21. Because these triangles, top and bottom, are congruent. They share an angle in the middle and two sides the same. So this angle, top and bottom is the same. So that means this is this is this, so on and so forth. Alright, SQR is the same as PRQ because these are both 13s. These angles are both the same as well. So that is 69 as well. And PSR is 90, since that is the right angle on the rectangle. So key thing here on the rectangle, the angles are 90, the entire angles. PSR, QRS, SPQ, RQP. Those entire angles are 90. Alright, next one. This is a rhombus. MK is 28. That means this is 14 MN and this is 14 NK. Why? Because it's bisected. That applies to every parallelogram. So 14 would be the length of NK. NL is 12. That means JN is also 12, which means JL is 24. Alright, the angles. MKL is 43. On the rhombus, the angles are bisected. So if this one's 43, the one next to it's 43. And then also these ones underneath are the same as those as well. Those are both 43 as well. Since opposite angles are congruent on a parallelogram. Alright, that gives me 43 and 43. That gives me 86. That leaves me with 94 for the other two angles to be total. Which means these other two have to both be 47s. Half of 94. Alright, so let's look over our work here. MNL. MNL. That is 90. The diagonals are perpendicular on a rhombus. JKM. JKM is 43. KJL is 47. JML is 86. There we go. Right, this one's a square. So if WZ is 31, so is XY. So is ZY. And so is WX. Because the sides are all congruent on a square. So ZY is 31. WY would be twice the length of WR. 21.9 times 2 times 2. 43.8. And coincidentally, we could also do the Pythagorean theorem there. 31 squared plus 31 squared to get 1922. The square root of 1922 gives us the same answer. Could have also did the Pythagorean theorem there to get WY. Alright, RX is the same as WR, 21.9. The angles on a square are all 90, the whole angles, and then the bisected parts are 45. So WRX, that's 90, since the diagonals are perpendicular on a square. XWZ is 90 as well. XWY is 45. Alright, so which of the shapes matches the criterion? All four sides are equal, so that's either a square or a rhombus. The diagonals are equal, that's a square. The sides are equal and the diagonals are equal. Opposite sides are equal, that's all of these shapes. And diagonals are not equal. Well, the diagonals are equal on a rectangle, and they're equal on a square. On a rhombus, they're not equal. On a parallelogram, they're not equal as well. But a rhombus has all the sides congruent. So this is a parallelogram. Because a rhombus has all four sides congruent, not just opposite sides. Opposite sides equal, and diagonals equal. That's a rectangle. Again, a rhombus has all the sides equal, and diagonals different. A square has all sides equal. Alright, all sides equal, diagonals not equal. That's a rhombus. Let's see. Alright, last question. You're going to do 6 distances for me here, just like we did yesterday in class. Distance of AB, distance of BC, distance of CD, distance of DA, these are the sides. So from A to B, there's 3 and 2. 3 squared plus 2 squared. 13. How did I get it so quick? Well, 1 negative 2 to 1 is 3 apart. Negative 7, negative 5 is 2 apart. We've done enough of these, you should be able to get these without too much effort. B to C, 3 squared plus 2 squared as well. So this tells me adjacent sides are congruent. So this tells me most likely that all the sides are going to be 13s. I'm going to go through and I'm going to check the work. But because the opposite sides are already congruent, it's told me right now that almost for sure all of them are going to be 13s. C to D, 3 squared plus 2 squared. Oh, 13. Now it is a negative 3, but again it's distance. So it doesn't really matter. I'll put it here. But it doesn't really matter because it's being squared as a quantity. And then D to A, same thing, negative 3 squared and then 2 squared. And technically those are negative 2 squareds as well. But that doesn't really matter, that part, because negative 2 quantity squared is the same as positive 2 squared. So all the sides are 13. So now I'm going to decide between rhombus and square by doing the diagonals. So distance of A to C and distance of B to D. To finish this question. So A to C, 6 squared plus 0 squared. Square root of 36. And then B to D. 0 squared plus 4 squared. The negative 5, negative 9 is 4. Or it's actually negative 4. 5 is 16. So these are different. That tells me it's a rhombus. Alright, so this question here takes a lot more time than the rest of the questions. It's going to be worth more points on the back. So the back will be worth 50 for me. This one will be worth more than the rest of them on the back. So make sure you do this last one, number 34. The rest of them will be worth, maybe 2 points each. Something like that to make it worth 50 on the back. How many is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There's 23 of these. So that makes sense to make them each worth 2. And make this one worth 4. Something like that. Anyways, I'll be after school if you got questions. Come in and ask. Good luck.